Hi, welcome to the first video of the channel Excel in Excel. In this video, we talk about how we use functions in Excel, and we'll start with financial functions. Whenever we are using Excel, there are a lot of things which you can do by just clicking on into the various options in the ribbon of Excel. But then when you want to do something which can be reusable, which once you create a model with formula, uh, another person who doesn't know how to use the formula can also come, change the values at certain cells, and the results, expected results in certain cells will show up. Now for that, the functions are very, very handy. And as I said in the introductory video, that this channel focuses on making business models, and therefore we have a bias towards using functions. So let us look at some of the financial functions. Let's take a scenario that I want to deposit 50,000 rupees today in a bank, and the bank gives me 6% rate of interest, and I want to keep that money for 7 years. 50,000, 6% interest, 7 years. And I want to figure out after 7 years how much money is the bank going to give me. Now, some of you will say, oh, we know that. We have studied that in school. And yes, this is the right formula through which we can do it. So we'll have the amount equal to principal, which is 50,000, 1 plus rate by 100, rate is 6%, so 6% by 100, to the power period, which is 7 years, and I should get the amount. Wonderful. You are 100% bang on, and you are correct. But what happens to some of us who don't remember this formula? We'll have to maybe Google it out, figure out what's the formula, and then do the job. Also, sometimes the questions might become a little more tricky. For example, let's take this scenario that I am putting 50,000 rupees to the bank today, and I want to keep it for 7 years. And at the end of 7 years, I want 1 lakh rupees to be returned to me. But then I don't know what is the rate of interest. I want to find out that rate of interest. So I will go to that bank which gives me that rate of interest, so that the 50,000 that I deposit today after 7 years becomes 1 lakh rupees. Now, yes, if you know this formula, you would have to do some algebra to find out, instead of amount equal to, you have to find a formula where rate equal to is something. And yes, with a little bit of algebra, you will figure this out. But why take that pain when we have Excel functions? So Excel or spreadsheet functions are there to make our life easier. We don't have to know the formula. We can just give certain values. For example, if there is a function which can calculate the rate for me, all I need to give to that function is the things that I talked about, that my principal is 50,000, that the period or the tenure of the loan is 7 years, and I want 1 lakh at the end of it. And the function will return me that value. I don't have to know what the formula it is using behind. So that's the beauty of using the functions. And therefore, once I have written that formula using that function, at any point of time, if I say no, I want maybe 1 lakh is too high, maybe 75,000 would do. So in the formula, I just need to change that amount to 75,000, and the new rate of interest will be given to me. So therefore, functions are very, very useful. Now, how do the functions basically look like? So typically functions look like, each function would have a function name, and it will take a series of arguments, out of which some of the arguments might be optional. That means you may not give it. You may not explicitly give it. So when Excel talks to us, what it does, when it gives a help, any argument that is within the square bracket, those are optional. So if we look at a typical function, there's a function called PV, and we'll come to it soon. We'll actually do it in Excel, and we'll see how it looks like. But what does it take? It takes an argument called rate, the rate of interest. It takes an argument called NPER. We'll see what that means. It takes an argument called PMT. It may take an argument called FV, and it may take an argument called type. But because these two are in square bracket, you may avoid giving them. If you avoid giving them, it will take some other default value for those. Now we'll see that. But if we look at financial functions in general, there is a list of arguments that most of the financial functions talk about or they take. Now, what are those arguments? So this argument are on argument 2. So let's understand the arguments that goes with a financial function. Now, one of the argument is PV, which stands for present value. Now, what does it mean? It means the total amount that a series of future payment is worth now. Okay, let's make it simple. So let's say I have I want to get 1 lakh at the end of 7 years, right? I want to get 1 lakh at the end of 7 years. And the rate of interest, let's say, is 6%. How much should I deposit? So what should be the present value? That means how much should I deposit today for 7 years at 6% interest, so that at the end of that 7 years, I get 1 lakh rupees from my bank. Now that's what a present value does, right? We'll see more examples of present value as we go in. If I take a loan, for example, if I take a loan of 1 lakh today, that 1 lakh is my present value, because today I have that 1 lakh with me. So that's my present value. So an amount that I deposit to the bank today, expecting some other value if in future, that's also a present value. If I take a loan of 1 lakh rupees today, that's also is a present value. And therefore, because these two things are different, one I am depositing and one I am taking as a loan, because these things have a different connotation, present value also have a sign convention. In fact, all the payments in Excel has a sign convention. It can be plus or it can be minus. For me, it's easy to remember that anything that goes out of my pocket is minus to me, and anything that comes to my pocket is plus to me. So if I'm making a bank deposit today, the present value, that's negative because I'm already making that deposit to the bank. It goes out of my pocket. On the other hand, if I'm taking a loan, that 1 lakh loan that I'm taking, it's coming to my pocket. So that's positive. Anything coming to my pocket is positive. Anything going out of my pocket is negative. So present value can be positive or negative based on what is the scenario we are talking about. Then there is the concept of future value. Future value basically means that if I'm making certain deposit or if I have taken a loan, what will be the future value of that instrument? So for example, if I'm having a recurring deposit in the bank and I'm paying every month, and this deposit is for 5 years. So at the end of the 5 years, what will be the value that I'll get given that particular interest rate? That is future value. Or if I take a loan today, that 1 lakh loan that I had taken, what will be the future value of loan? So if I'm taking that loan for 5 years, at the end of 5 years, that future value of the loan should be 0 because I would have repaid back everything. But at the end of 3 years, what would be the future value of that loan, right? So I can figure out a future value like that. And again, it can be positive or negative depending on whether it is coming to me or whether it is going out of me. The rate. Rate is basically the rate of interest. So the rate of interest per period. Now this per period word is interesting because normally when we talk of rate of interest, we talk of rate of interest per annum. Let's say a bank gives us 7% per annum. A mutual fund might be giving us around, let's say 11 to 12% per annum. If I am invested in stock, I might have got a more amount than that. So normally the rate of interest that we are talking of are per annum. But in this case, I have not written it as per annum, but I wrote per period. Now let me explain you this using the concept of NPA. NPA is basically total number of periods for any instrument. So for example, if I'm taking a loan, for say 5 years, then the period of the loan is 5 years. But the important thing is that how am I going to pay for that loan? If I repay that loan every 1 year, that means for 5 years I pay some amount at the end of 1 year, some amount at the end of 2nd year, some amount at the end of 3rd year, some amount at the end of 4th year, and finally I pay whatever is left in the 5th year, then NPAR is 5, right? However, if I am paying this monthly, then for example, when we are paying an EMI, if we are paying that amount monthly, then for 5 years I'll actually make 5 into 12, 60 payments, 60 EMI payments will be made, and therefore in this case N per would be 60. Now, if that was the loan which bank gave me at 10% rate of interest per annum, because I'm paying my EMIs monthly, the rate will have to be converted into monthly. So 10% per annum will basically means 10% divided by 12 per month. That is the reason why we had written rate of interest per period. So the period will depend on other things. So if I'm paying an EMI, the period will be monthly, right? If I'm paying quarterly, then the period will be quarterly, and so on and so forth. PMT is another argument, and that means the payment that we pay at regular interval, and this is a fixed payment. It cannot be changed during the life of the annuity, during the life of this payment cycle. So if I take a loan of let's say 1 lakh, and if I'm paying an EMI of 1000 per month for 5 years, then PMT is this 1000, and this should be same for the 5 years. That means every month for 5 years I'm paying 1000 back. 1000 back. Of course, that will not repay my loan of 1 lakh, but that's different issue. PMT therefore means that whatever I am paying at a particular interval. So if it is an EMI that I am paying, it goes out of my pocket. So in that case, PMT will be negative. On the other hand, if I had deposited some money in, let's say, a monthly income scheme in a bank, and every month bank is going to pay me the interest, then in that case PMT will be that amount that the bank gives me per month, but in that case it will be positive because that comes to me. So PV, present value, FV, future value, rate of interest per period depends on the payment cycle. If I am doing it monthly, then the rate will be monthly. If the payment is happening quarterly, then the rate will be quarterly. And same way, the total number of periods, N per, would also need to be converted according to the interval that we are talking of. Type. Now, let's take an example of a house rent. So when I take a house, what does my landowner expect or house owner expect? She might expect that I'll pay the rent in the beginning of the month. So for the month of January, she expects me that I'll pay this rent on the 1st of January. But I would love to pay it at the end of January. That let me stay January, and on the 31st of January, I'll pay you the rent of January. Now, if my landlady wins the argument, then that means the payment is done at the beginning of the period. On the other hand, if I manage to win the argument, chances are less, but if I win the argument that I'll pay you the rent of January on the 31st of January, then the period is at the end of the period. Now, typically, therefore, when we take loans or when we make some deposits, say for example, if you are making a fixed deposit, what bank does is bank pays you the interest quarterly. Now, that means when you make a deposit today, the bank will pay you the first interest, especially for a fixed deposit. The bank will pay the first deposit at the end of 3 months. That means at the end of the period. They don't pay you that first interest today. And therefore, type would be 0 when we are talking of calculation based on end of period. However, if there was a situation that I deposit a money to the bank and the bank will pay me interest quarterly, but the first slot of that interest, the first round of the interest it pays me today, it will be beginning of the period, and in that case type will have a value 1. Most of the time it is the end of the period, because we are not talking of house rent, we are talking of bank deposit, loans, etc. So most of the time these are calculated at the end of the period. So the default value of type is 0. That means end of the period. Per, like N per also talks of period. But then what it is and when do we use it? Now, for example, you are paying an EMI. So you have taken a loan and you are paying an EMI every month. So as we go on paying the EMI, the outstanding amount, for example, I had taken a loan of 1 lakh. After I pay the first installment, my outstanding loan is not 1 lakh because I would have paid back something. After my second installment, the outstanding amount will come down a little more because I have paid some amount of principal back. So every EMI consists of a amount of principal repayment and of course an interest component. So if I want to know what is the interest that I am paying, let's say in the 10th EMI, then PER will be 10. If I want to know what is the interest I am paying in the 24th installment of the EMI, then in that case PER will be 24th. Naturally, the interest that I am paying on 24th installment of the EMI will be less than the interest I am paying in the 10th installment of the EMI, because in the 10th installment my outstanding amount will be more as compared to the outstanding amount when I pay the 24th EMI, right? But then what happens if I want to find out what is the interest that I am paying in the entire second year? Now, entire second year basically means starting from the 13th EMI till the 24th EMI. And in that case, the start period and end period becomes important. So, if I want to find out what is the interest I am paying in the second year, as I said, in that case, I will put the start period as 13, end period as 24. All those 12 EMIs that I would have paid, what is the interest that I would have paid in that? So in that case, start period and end period becomes interesting. And one of the last of the arguments is guess. Now, why do you need to guess first of all? You are doing calculations. You can't just guess, right? Okay, we are not totally right as far as Excel is concerned. But by the way, when do you get this guess argument? This guess argument is used when the function calculates some sort of interest. And if you do not give, most of the time guess would be optional. That means it will be within the square bracket. And you would see you can avoid it. If you avoid it, it takes a default value of 10%. Okay, right. 10% basically means 0.1. But what does it mean? Why do I need a guess? All right, so let's understand that. To understand that, let us try to understand how Excel actually computes values. Remember that question that we had started with, that I pay to the bank 50,000 today. That means I deposit 50,000 today. After 7 years, I would want 1 lakh rupees back from that deposit. What should be the rate of interest? Now, if it was you and me doing it on a pen and paper mode, we would have done some algebra calculation on this and we would have found a formula rate equal to something. But unfortunately or fortunately, Excel doesn't do that. Excel will continue using this formula. It won't bother about any algebraic transformation. What it will do is, it will put this 50,000 that we said as the principal. It will put 7 years as the period. Now the rate, the default guess value, it will put 10% as the rate of interest. And it will calculate what is the amount. Now let's say, calculating at 10% rate of interest, okay, at 10% rate of interest, it finds out that the amount is going to be, let's say 90,000. But we wanted the amount to be 1 lakh. And therefore, Excel will do the calculation again, but now it will take the rate more than 10%. It started with 10%. With 10%, it could not match the expected value, that is 1 lakh. And now, therefore, it might make it 11%. And then check what is the amount. So, Excel does the computation iteratively, right? Now, at 11% when it calculates, it might find that the amount is coming to, let's say, 95,000. But it's still less than 1 lakh. So, next maybe it will put the rate at 12% and calculate. And at 12%, if it becomes 1 lakh 2,000, then it will again calculate, and now this time it will try to further coincide the result with 1 lakh that you expected, and therefore now it will reduce the interest rate from 12%, somewhere between 12 and 11%. Now it knows the answer would be, and it will iteratively find out what that amount would be. So it's like a salesperson putting the amount in the balance. Let's say you are weighing 1 kg of sugar, so put a little more. Oh, it's more than 1 kg, take a little less. Oh, it's now has less than 1 kg, put a little more. And that's how iteratively the Excel calculates, for example, the rate here. And of course, given this process, it will if everything else is correct, it will calculate the rate correctly. why do we therefore need a guess? Typically, we don't need a guess as long as we have a equation for the rate which results in a single answer. So consider these two plots. So consider the one which is on the left hand. Let's say the value at the x-axis is my answer. So in this case, it is 70. Let's say the rate of interest is going to be 7%. Now, depending on your equation for the rate, the function for the rate, it will start at 10%. And if the answer is 7%, at 10% it will figure out the rate of 10% is higher than what you are expecting. And therefore, it will go on reducing, and ultimately it will come to the 7%. And maybe at the 7%, it finds out what you exactly looked for. So in our example, maybe at 7%, you really got that 1 lakh as the amount. And so 7% is the answer. You don't need a guess to be provided here. As I said, if you do not provide the guess, it will start with 10%. So it will start with 10%, it will go down, and ultimately at 7%, the result will be there. But what happens if your function is not a linear function? If your function, the formula for your rate gives two values or multiple values. Now, in that case, what happens? Say, take the right hand side. Say the rate of interest function actually resulted in two values. One is 1% and the other one is 5%. Now, therefore, when you start using Excel to give you this result, as we discussed, if you do not give a guess, Excel will start from 10%, right? Excel will start from 10% and then it will come down because it will not match your answer at 10%. So 9%, 7%, 8%, 6%. Ultimately at 5% or near about 5%, it finds out that this is the point where the x value is 0. That means it cuts the x-axis and your result will be that near about 5%. Now, while you will be happy with that result, you don't know if there was another possible result, right? You don't know that whether this result is an unambiguous result or there were other possible values which solve that equation. Now, if I would have done that, what I would have done, I would have calculated once, maybe without giving the guess value, it will start with 10% and it will go. And second time, maybe I'll start with giving a guess value of maybe let's say 0.5%. Now, if I give the guess value as 0.5%, it will start here and then it will move up and it will get this result near about 1%. So one gave me an answer near about 5%, the other gave me a result of near about 1%, and therefore I know that there are at least two results. So I can try a few more with different giving guess values. Maybe one guess I can give at 90%, one guess at 50%, one guess at 0%, one guess at 60%. Like that, if I give a few ones, I'll know whether the answer is there is only a single solution to the equation or there are more than one solution to the equation. Most of the cases, if there are more than one solution, I can't use that function. For example, if I'm saying at what rate of interest I gain that, and if somebody says the rate of interest can be 5% or the rate of interest can be 1%, that really don't make a practical sense most of the time. And therefore, whenever we are using a guess, we are basically trying to see whether there is a single distinct answer or there is more than one answer. Moment we find more than one answer, of course, it's not useful to us anymore. So that's the idea behind guess. So if we have understood all this, now we are in a position to actually work out with the functions. So the first function is PMT, which takes rate, NPER, PV, FV and type as arguments. FV and type are optional. I forgot to put those square brackets. What PMT does is it calculates a periodic payment value, right? So if we are, for example, if I have taken a loan or if I am planning to take a loan, I know what is the loan amount, that is the PV. I know for what is the period I am taking the loan, and I know what is the rate of interest. I want to find out what the EMI would be. In that case, I can use a PMT. So let's take an exercise in Excel and do it hands-on. Now, in this case, as you can see, we have, let's say there's a loan amount, which is 80,000 rupees. and the rate of interest per annum is say 10%, and the loan needs to be repaid in 20 years. Now PMT, the function PMT, is something which gives me the amount of a periodic payment. Remember, when we talked of the argument, we said PMT is a periodic payment. So the function PMT helps us calculate a periodic payment. So therefore, when I'm talking of EMI, EMI is a periodic payment, and therefore, how much is the EMI? If I want to calculate how much is the EMI, I can use the function PMT. Now, as you can see here, it asks me what is the rate, what is the N per, that is the total number of period, what is the PV, and FV and type are optional here. Now, therefore, it's a loan, right? It's a loan. So what is my rate of interest? So first it asks me the rate of interest. So the rate of interest is 10%. However, mind you that it is a monthly installment. So the rate of interest which is given per annum, I'll divide it by 12, and therefore we have the interest rate per month. N per, what is the total period? Now total period is of course 20 years. However, we are talking of monthly installments, so we'll multiply it by 12 so as to get how many monthly periods are there, right? And then it asks me for the PV. PV is of course 80,000. It's a loan, so the money comes to my pocket, and therefore it is positive. Now as you can see, FV and type are within square brackets. So FV, the future value, because it's a loan, if I don't give any future value, it will be considered as 0. That means I'm going to pay back the entire loan. So if I do not give FV, a value of 0 will be considered. Type, if I don't give a value for a type, again a 0 will be considered, because it will be considered that the interest is payable at the end of the period. That means at the end of every month. And therefore, without giving any of those two optional values anymore, this is the formula that I have. And as you can see, the amount comes as 74,570.50. This is a negative value actually. My Excel is configured in such a way that a negative value comes in red and with a bracket inside. So there is a negative value. Mind you, this is the amount that will go out of my pocket every month for 120 months, and therefore this is negative because it goes out of my pocket, right? So that is the first function, which is PMT. What is the next function? Okay, what is the interest component of the EMI? When I'm talking of the 20th installment, I can calculate it using IPMT. I standing for interest, and PMT of course is the periodic payment. Now it asks me for the rate, and similar to last time, the rate is of course 10%, but it is monthly, so divide by 12. Then it asks me for per. Per is the particular period for which I am calculating the interest, and let's say I am calculating this for the 20th installment, right? I am calculating this for the 20th installment. So I am trying to figure out what is the interest component in the 20th EMI that I would be paying. So therefore, I put the period as 20. What is the total number of period? N per. That is of course 20 years into 12 months that we had already discussed. And of course, what is the present value? Present value is this 80 lakhs. And of course, it's positive because it's a loan, came to my pocket. And therefore, you see, this would give me what is the interest component in the 20th installment of my EMI, and that is 61,517.07. Again, this is a negative value because this also goes out of my pocket. Now, once I know this, if I want to figure out what is the principal component of the 20th EMI, I can easily find out this was my total EMI at B5 minus the interest component, and that is the principal component. So in the 20th EMI, for an 80 lakh rupees loan at 10% per annum for a 20-year tenure, the 20th installment would have around 61,500 as the interest component, and just around 13,000 as the principal component. Continuing with the next financial function is CUMPRINC, which stands for cumulative principal. And here you see there are rate, N per PV, and now there's a start period and end period. So for example, if I want to find out what is the total principal that I would have paid in the first year, this function can help me, because for the first year, the start period would be 1 and the end period will be 12. So first to 12th EMI, what is the total principal that I would have paid? Similarly, if I have a question that what is the cumulative interest that I would have paid, then CUM IPMT will be the function that will help me out. And therefore, let's look into that and try to answer that in Excel. So now we can see that we are asking this question, what is the principal repaid in third year? So the principal repaid in third year would be, it will be cumulative principal, because third year means 12 EMIs, so cumulative of that. So CUM PRINC, so cumulative principal, that's what we are looking at. The rate, like all the time, we know what's the rate, we'll divide it by 12. N per, again 20 years multiplied by 12. But now it asks me the start period. Now since we are looking at the third year, the start period will be starting from the 25th EMI and end with 36th EMI. And this time, what did I miss? Sorry, I missed the PV. Just hold on. Yeah, so see here, PV is highlighted, so I should give the PV like last time. And now I need to give the start period, which is 25, and the end period, which is 36. And in this case, type is not optional, so I have to give the type. Since it's end of the period, that means the first installment is at the end of the month, and therefore I type 0. Now this is the formula that I'm going to use now. So the best part here is that you see, when I'm trying to find out the cumulative principal that I'll pay back in the third year, thanks to the Excel function, but if it was not there, I would have to figure out at the beginning of the third year, what would be the principal outstanding, how much will I have paid in the third year, all those difficult calculations would have come in. But in this case, I don't have to bother. I just have to remember that my initial rate of interest is 10% divided by 12. The N per is 20 multiplied by 12. The PV is 80 lakhs, and that I'm starting from 25th installment to 36th installment. And so this is the cumulative principal that I'll end up paying in the third year for this particular loan. Similarly, if I want to find out what is the interest paid in the first year, I can always use CUM IPMT, because now we're talking of the interest. And by now you know how you go about it. 10% divided by 12, N per 20 into 12, the PV is 80 lakhs, and because it is the first year, so start period is 1, end period is 12, and we know we want at the end of the period. So the interest paid in the first year would be 7,53,970.85. Similarly, using the same formula, if you want to calculate what will be the interest paid in the third year, again it will be CUM IPMT. The rate, of course, is 10% divided by 12. Period is 20 multiplied by 12, that is the N per. The PV is 80 lakhs. But now we're talking of third year, so from the 25th installment to 36th installment, and end of the period, which is 0, and that's how it comes out to be. So as of now, we have looked into a PMT formula, we have looked into a IPMT formula or function, we had looked into a CUM PRINC function, and we have looked into CUM IPMT function. So we have looked at 4 different functions as of now. So let's continue and let's see what is the next function. The next function is rate. So remember, we talked about the guess, and in this case, as you can see, when I use a formula which gives me a rate, guess is there. Of course, this is optional. So The rate of interest given, if I know the total number of periods, if I know what is the EMI that I am paying, what is the present value, what is the future value, etc., I can figure out what is the rate of interest. So let's again work this out in Excel. Now, let's say I plan to buy a wonderful car, the best I can think of. And that particular imported car is going to cost me around 80 lakh rupees. So I want to figure out, can I really buy that car? So I look at my finances and I see that the EMI that I'll be able to pay per month would be just about 50,000. Now, if I take a 20-year loan, would I be able to pay that 80 lakh loan paying 50,000 EMI in 20 years? And if I can do that, what will be the rate of interest that I'm looking at? So the rate of interest that I'm looking at would be given by the rate function. It needs the NPER, right? Which is 20 into 12. Now the PMT is the EMI, the periodic payment that I'll be giving. Now this is going to go out of my pocket, and therefore let's put a negative 50,000 this time because it is going out of my pocket. And then what is the present value? Present value is that 80 lakh loan that I am looking for. And yes, I may not give the other things because other things are, as you see, FV. For a loan, it will be considered as 0. For a type, it will be considered as the end of the period, 0. Guess, it will start with 10%, as we had already explained. And therefore, what is the rate of interest? The rate of interest would be 363. But mind you, 0.363%, of course, it's a very low rate of interest. But is this interest per annum? No. For all this, we had converted everything into month, EMI. It's monthly. So this is the rate of interest per month. And therefore, if I want it, I have, as a year, I have to multiply it with 12. And therefore, this is the rate of interest. So I found out the rate of interest. Rate of interest will be in the same calculations as the other things. Now here I had considered EMI, and that is monthly, and therefore I also converted the NPER into monthly, 20 into 12, that's what I had done. Therefore the rate of interest came out as monthly, and therefore I need to multiply 12 to get the rate of interest. So right, I can buy that 80 lakh rupees car, paying an EMI for 50,000 for 20 years every month, provided I get a bank who is ready to give me a loan at a rate of 4.358% per annum. That's going to be a little challenging in our country at this point of time. Right, so let me give up the idea of buying the car for the time being, and let me look into another Excel function. The next Excel function let's look at is FV. Now that stands for the future value. Future value is useful, for example, to understand if I'm making a sort of an investment. Let's say I'm making an investment in a mutual fund, or I'm making an investment in a bank deposit. In that case, what will be the value of that investment after a certain amount of time? The future value. So for the future value, let's again try to work this out in Excel. Let's say I have a amount of 1 lakh rupees with me, right? I have a amount of 1 lakh rupees with me today, and every year I'll deposit 25,000. And the rate of interest per annum is 6%, and I want to continue this for 10 years. Now in that case, what will be my amount? What will be the amount at the end of 10 years? Now what am I saying is that today I have 1 lakh which I'll put into the bank. Every year for 10 years I'll deposit 25,000 per annum. The rate of interest is 6%, and the deposit is 10 years. Now in this case, as we can see, that everything is in terms of year, so I don't have to convert anything into the month. So the future value FV, what it asks? It asks for the rate. Now the rate is 6%. I'm not going to divide it by 12 because I have nothing monthly. I have everything annual here. Number of period is 10 years. Again, I don't have to convert monthly because we are talking of annual deposit. We are not talking of monthly deposit anymore. And there is the PMT. PMT is the periodic payment, which is 25,000 that I'm going to pay every year. And therefore, it will go out of my pocket. So minus of 25,000. And then what is the present value? Present value is 1 lakh, but that is also what I'm going to give to the bank. So that's also negative because it goes out of my pocket. And type is optional, so let's leave it out. It will consider it as the end of the period, and therefore my future value of this deposit will be 5,08,604.64 after 10 years. And this is positive because the bank is going to give me back that money. What happens if I do not make any monthly deposit? Let's say I put 1 lakh rupees today in the bank, keep it in the bank for 10 years at a 6% interest. That means there is no monthly payment. However, I'm making an assumption that the bank will compound the bank will give me the interest quarterly. So it is a compound interest case, and of course it will be compounded quarterly. As you know, compounding is a very powerful method of making money. So again, I'm looking at what will be the amount at the end. So FV, future value. Now since I'm talking of quarterly, this is 6% per annum. So per quarter it will be divided by 4 because there are 4 quarters. So 6% divided by 4 is the quarterly rate of interest. N per is 10 years, but then we are talking of 4 quarters in a year. So we'll multiply by 4. PMT, there is no periodic payment. We are not giving any periodic payment. That means I'm not paying that 25,000 per annum. So there is no PMT. So I'll leave it blank. Now to leave it blank, if I type in something, Excel will think that I'm giving the PMT value. But I want to give the PV value, that is what am I depositing to the bank today, and I don't want to give a PMT value. So how do I make Excel understand that? A extra comma. That means I haven't given any PMT. So this extra comma becomes a placeholder to tell Excel that no value of PMT has been given. And the PV is 1 lakh, which I am giving to the bank today, and therefore it's negative. And therefore that's the amount that I will get at the end of 10 years for a deposit of 1 lakh at 6% of interest rate compounded quarterly, which typically a fixed deposit does. What more can we look at? Let's say I don't put any lump sum payment. That means I don't put that 1 lakh payment today. So there is no PV that I'm looking for, but I'm only making this monthly deposit. Now this time I'm saying my monthly deposit is 25,000. Previously I said it was an annual deposit, but now I'm changing it and I'm saying my monthly deposit is 25,000. And I want to know what will be the future value. So FV, rate, of course rate of interest remains same, but now I'm talking of monthly deposit, and therefore I need to divide it by 12 because now I'm getting the period in terms of months. So first case it was in terms of year, second time it was in terms of quarter, now I'm doing it in terms of month. Total number of period is 10 years but into 12 months. I'm going to give 25,000 per month, but again this will go out of my pocket. So minus of this 25,000. There is no PV and therefore I can leave it blank. I don't give that value because that was optional, and therefore this formula should get me this. So if I make a deposit of 25,000 every month for 10 years and the annual interest rate is 6%, then my final amount would be around 40 lakhs 96,000 or rather 97,000. Just the next function is PV, the present value. For example, if I know that I want that much money. So I want to go for that European holiday. And for that, I need a particular amount of money. The question is, I am planning that holiday 2 years down the line, and I'll start saving from today. So, how much would I need to save today? And if I want to save every month, how much do I need to save every month to get to that amount which will take me to that European holiday? So, therefore, to calculate this, let's again look into Excel. Let's say whatever I want to do, maybe an European holiday or maybe to build a house, uh, I want to have a future value of 1 crore rupees. Maybe this time I'm putting my money in a mutual fund, and I expect the mutual fund to return me around 9% interest per annum. I want to keep this happening for 15 years, and I want to put every month 25,000 rupees. Right? Every month I am going to put 25,000 rupees for 15 years at 9%. I want to reach the goal of 1 crore. The question is, what should be the amount today that I must have in my hand, which I should also deposit in order to get that 1 crore? So, let's look at the formula PV, present value. Now, what is the rate? 9%. But again, since we are going to put 25,000 every month, our interval is monthly, and therefore interest rate has to be monthly. So we divide by 12. NPA, it's 15 years. So into 12 months. PMT, so every month I will put 25,000. That means that 25,000 will go out of my pocket. So minus this. And FV and type are optional. So I leave it out. Sorry, I can't leave it out because my future value is going to be this, and type is optional, of course. In that case, I'll need to deposit 1,40,659 today to reach to that future value. What does it mean? It basically means that if I just pay 25,000 every month for 15 years at 9% interest rate per annum, I will still not reach 1 crore rupees. To do that, today I'll have to save 1,40,700, say 660 for now, and every month I'll have to give 25,000. In that case only, I'll be able to reach this. So this is my lump sum initial deposit that I'll have to make. And lastly, if we say, fine, we are not going to have any monthly payment. So it's a one-time lump sum that I'm going to make the payment, and I want to get that 1 crore at the end of 15 years. What should be the amount that I should deposit today? So the present value, the amount that I should deposit today, keep it in the bank for 15 years or keeping it in the mutual fund for 15 years, hoping that I'll get 9% interest per annum, and the future value will be 1 crore. In that case, the rate is 9% here. Since there is no monthly payment, I will not convert it into monthly. NPA is 15 years. There is no periodic payment, so likewise before, an extra comma, and the future value is that 1 crore that I want to get back. So today I'll need to deposit 27,45,380 in an instrument for 15 years, which will give me 9% interest per annum if I want that at the end of the day I should have, or end of 15 years rather, I should have 1 crore in my kitty. These were some of the Excel functions that we looked at. These are basically financial functions. They all talk of financial aspects. As I said in my introductory video, that I hope you would have worked on along with me to better understand this. I would encourage you to try out different sort of things and figure out how to use these functions. These are very, very useful for our personal finance also. So if you are planning to, say, have a European holiday, or you want to buy that car, or you want to build a house, or you have started your career and you are planning to retire early, and you want to have a retirement fund, which will allow you to retire early, and you want to start saving from today, you would have an idea of how much you would need to save to get to that retirement fund once you have done your basic calculations correct. And the functions that we discussed today will help you in deciding on those. So, till we meet next time, keep learning. Thank you.